everyone, I'm Aliyah Erica A. Javier, BSCE 3G, and this is MECH 312, Dynamics of Rigid Bodies. So for absolute motion, I choose example number 1. A wheel of radius r rolls on a flat surface without slipping. Determine A. The angular motion of the wheel in terms of the linear motion of its center O. And for letter B, the acceleration of a point on the rim of the wheel as the point comes into contact with the surface on which the wheel rolls. So, first, for letter A, so we have a position S, and this is also equals to our radius and theta. So, and then the initial velocity, by getting this by simply multiplying the radius and then the angular velocity. And also, it is equals to uh, first derivative or s prime of the position. And then, by getting the initial acceleration, so we have r angular acceleration, r multiplied by angular acceleration, and also it is equals to second derivative of the position s. So in this problem, we don't have any values, we don't have any given values, so therefore our final answer is in terms of variables. So in letter A, this is our answer. And for letter B, again, the acceleration of a point on the rim of the wheel as the point comes into contact with the surface on which the wheel rolls. So when the point C move along the path to the point C prime, so the coordinates and the time derivatives is varied. So for coordinates x, it is equals to s, or the position, minus r sine theta. And also it is equals to our s is equals to r theta minus r sine theta. And then by factoring this, we have r theta sine theta. And then using the derivation by getting the first derivatives of x, so we have r theta 1 minus cosine theta. Since it is theta prime, this theta prime is equals to angular velocity, so therefore it will become radius multiplied by angular velocity, and this is also equals to initial velocity, so therefore it will become x prime bo times 1 minus cosine theta prime. And then after that, next is getting the second derivatives. So for second derivatives, we have b sub o prime 1 minus cosine theta plus b sub o theta prime sine theta. And then x second derivatives, acceleration at point O minus multiplied by 1 minus cosine theta plus r angular velocity squared sine theta. So this is for coordinate x. And then next is for coordinate y. So we have r minus r cosine theta. And then by factoring, it will become y is equals to r minus 1 cosine theta. And then next, first derivatives of y. So we have r theta prime, then sine theta. And again, this theta prime is equals to angular velocity. So therefore, it will become d sub o multiplied by sine theta. And after that, we proceed to the second derivatives of y. So for second derivatives, we have v sub o prime multiplied by sine theta plus v sub o theta 1 cosine theta. And then y second derivative acceleration, initial acceleration multiplied by sine theta plus it will become radius multiplied by angular acceleration squared, angular velocity squared multiplied by cosine theta. So this is our for coordinate y. And then if when our data is equals to 0, so therefore our x prime, when the data is 0, so cosine 0 is equals to 1, so 1 minus 1, it will become 0, so multiply by this, it will become 0, and then this sine theta, or it will become sine 0, it is equals to 0, so therefore it will also become 0. So the second derivatives of x is equals to 0. And for double prime y, and then for sine 0, it is equals to 0, so therefore it will become 0, and plus cosine theta or cosine 0 is equals to 1. So therefore, we have an answer of r radius multiplied by angular velocity squared. So this is our answer for absolute motion, example number 1.